Today we are going to be looking at Unit 7, Learning Target 5. I can approximate the value of irrational numbers and locate them on a number line. So if you remember back from Learning Target 1 when we were identifying rational numbers versus irrational numbers were defined as any number whose decimal expansion does not terminate or repeat. And we talked about a hint that lets us know if it's irrational. A main clue is that it is a square or cube root of any number that is not a perfect square or a perfect cube. So that's going to be how you can identify whether or not it's an irrational number or if it is rational. So we're going to look at this first example here, and we have 6 numbers, and we want to identify which are irrational. So this is where it'll be helpful to look back at your notes from LT1. Actually, I take that back to LT4 because that has a list of our perfect squares and perfect cubes that you can refer to if you don't have them memorized, which is okay if you don't. So question 1 or example 1 says the square root of 5. Well, are there any factors that I multiply by themselves that would give me 5? There is not, because 4 is actually a perfect square, which is 2 times 2, so 5 would definitely not be one. So 5 is irrational. The square root of 16, are there any factors that I could multiply by itself that would give me 16? We know that there is. That would be 4, so that is not an irrational number. Number 3 is the square root of 10. So square root of 10, we can be pretty confident that there are no factors if you multiply a number by itself would give us 10, so that is also irrational. Cube root of 510, so cube root, a number times itself 3 times, that would give us 510. There is not one, so that is going to be irrational. The cube root of 729, so is there a number when I multiply it by itself 3 times that would give me 729? And if you look back at your chart, there is, and it's the number 9. So that is a perfect cube, so that is not irrational. And then number 6 is the cube root of 119. And 119, if you look at your chart, it is not a perfect cube, so that is irrational. So to help us estimate the value of our irrational numbers, obviously the simple thing to do would be to plug it into your calculator. But as you remember from the beginning of the year, I mentioned that this is one of those units that we will not be using a calculator, because if we were taking a state test this year, you would not be allowed to do that. And so we're going to be teaching to the standard as it is set up. So to estimate irrational numbers, we can use this colorful little chart that I have set up here. And this is actually something that I had just learned how to do a couple years ago. I saw it laid out this way, and I really enjoyed it because I think it makes it pretty foolproof as long as you follow the steps step by step. So the first thing that we are going to do, so we're going to use our first example, which is the square root of 5. So if I want to estimate the square root of 5 to the nearest hundredth, I'm going to write the square root of 5 at the top. That's the number that I'm working to estimate. So I have to ask myself, between what perfect squares is the square root of 5? So we had talked about, when we circled it, that is between the square root of 4, which is 2 times 2, and then the other perfect square that it would be in between, it would be between the square root of 4 and the square root of 9, which the square root of 4 is 2, and the square root of 9 is 3. So we know that the square root of 5 is going to be some decimal expansion between the whole numbers 2 and 3. Now we don't know exactly which yet, but we know it's going to be in between there, which would make our whole number 2, because that's going to be 2 and something, 2 point something, 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 which is what we're going to calculate. So the first thing that I want to do is find what is the difference between 4 and 5. Well, the difference between 4 and 5 is 1. And then what is the difference between 4 and 9 right here? So if I subtract 9 minus 4, that gives me 5. So if I go over to my little chart here, I would have that it's 2, and then my numerator would be 1, and my denominator would be 5. So the square root of 5 would be approximately 2 1/5. Now that's wonderful. We have our fraction. However, we want to get a decimal. We want to round to the nearest hundredth if we can. So I'm going to take my fraction and I'm going to divide it. Alright, so if you need help, I kind of gave you a color coded here. Remember, your numerator goes on the inside of your fraction house. Your denominator goes on the outside. 5 does not go into 1, so I have to add a decimal point and a 0. I bring up that decimal point. 5 goes into 10. 2 times 10, or I'm sorry, 2 times 5 is 10. If I subtract, I get 0. So for this one, I cannot round to the nearest hundredth because it would just be 0. It's a terminating decimal. So the estimated value of the square root of 5 would be 2.2, which if I'm putting that on my number line, let's see, this would be 2.5 here. So 1, 2, 3, 4. So we would say that the square root of 5 is approximately right there. Now again, this is an approximation. If you were to type that into your calculator, so I'm going to do that right now. So if I typed in the square root of 5, it gives me the actual answer. And again, actual meaning it's still rounded because irrational numbers, the decimals go on forever. But it's 2.236, so on and so forth. So our estimate of 2.2 was pretty close. And that's the extent of what you need to be able to do with these. You need to get it pretty close, pretty good estimate. All right, so let's look at our next example. Our second irrational number that we had was the square root of 10. So if I go down to my chart here, so the square root of 10, that's going to be in between the square root of 9, which is a perfect square, and the square root of 16, which is a perfect square. And again, this is where that chart will come in very handy if you look back at your unit or LT4 notes. And the square root of 9 is going to be 3. The square root of 16 is going to be 4. So we know that the square root of 10 is going to fall somewhere between 3 and 4. So the whole number is going to be 3. Then I'm going to go and find the difference between 9 and 10, which we can do that in our head. That's 1. And then the difference between 9 and 16, and that is 7. So we would get an approximate value of 3 1/7. So then if I want to make sure that I have that in decimal form, okay, it would be 1 divided by 7. 7 does not go into 1, so I'm going to put that decimal point and my 0, bring up the decimal point. 7 goes into 10 one time. 1 times 7 is 7. We subtract, we get 3. Add another 0, bring that down. 7 into 30, it goes 4 times. 4 times 7 is 28. If we subtract that, we get 2. And because I'm rounding to the nearest hundredth, I do have to go one more place to make sure that I'm rounding correctly. 7 goes into 20 twice. That would give us 14. Okay, so I have my approximate value for the square root of 10 would be approximately 3.14. So if I go back to my number line, 3.1, let's see if this is 3.5 in the middle here. 1, 2, 3, 4. Ooh, those are not evenly marked. But again, 3.14 would probably be about there. So that would be your square root of 10. Okay, for cube roots, we have the cube root of 510. So the square root, or cube root, the cube root of 510 510. I'm going to add my cube roots here. Okay, so I have to find between what perfect cubes is 510. So if I look at my chart, I can see that that's going to be between the cube root of 343 and the cube root of 512, sorry, and that is going to put it between the whole numbers 7 and 8. So I know that the cube root of 510 is going to be approximately 7 point something. So then if I find my differences, so 510 minus 343, and if you want to use a calculator for this quick math, that's okay. Obviously, you could do subtraction by hand as well, but for the sake of time, if you want to just quickly calculate that, that's okay. And then the difference between 512 and 343 is going to be 169. So that would give us the fraction 7 and 167ths over 169. Okay, now we can do this math, and we can say 167 divided by 169. Okay, that's definitely going to be a bigger problem than you want to anticipate, but look how close 169 is to 167. If I were to multiply 169 by 10, it would give me 1,690. So it's definitely going to be less than that. So we'll say that this is going to go in about 9 times. And 9 times 169, and again, if you need to use a calculator for those quick calculations, that is fine. Okay, so that's 1,521. So if we subtract that, 1,521, that gives us about 149. Bring down a 0. 1,490 divided by 169 gives us about 8. So 8 times 169 is 1,352. And if I subtract that, and gives me about 138. If we go one more space, 1,380 divided by 169 will give us another 8. Okay, so we can stop there, and I can see that this is going to round, so I would get approximately 7.99 as my location, which is obviously very close to 8, so the square root of 510 is right before 8. Now, you might have already noticed that it was going to be that close to 8 because 510, the cube root of 510, is really close to the cube root of 512. 510 and 512 are only 2 units apart, so you can pretty much estimate, even without doing any of this work, that that's going to be really, really close to 8. Okay, for our last one, we have the cube root of 119. Okay, so cube root of 119, and we want what are the perfect cubes that this is between. So 119 is going to be the cube between the cube root of 64 and the cube root of 125. So this is going to be between 4 and 5. Okay, we should be able to see 119 is closer to 125, so it will probably be closer to 5 than it will be to 4. However, that whole number is still going to be 4 and something. So 119, take away 64. What's the difference between 119 and 64? That is 55. And then the difference between 125 and 64, that gives us 61. So our approximate value would be 4 and 55 61sts. So then if we go ahead and do that division, so 55 divided by 61, okay, 61 into 550 is about 9, and so 9 times 1 is 9, 9 times 6 is 54. So if we borrow, that would be 1. Okay. So if we bring down that 0, 61 does not go into 10, or it goes in 0 times. Okay, so 0 times 61 is 0, subtract, we get 10. If we were to bring down another 0 just to see what we'd have to round, 61 goes into 10 once, and we can kind of stop there. So we would get that our approximate value would be 4.90 if we were rounding to the nearest hundredth. So 4.90 would be pretty close to 5, not as close as our previous example, and that would be the cube root of 119. I actually need to go back up here. This would be the cube root of 510. Okay, so then if we're putting these on the number line, we can see we have an example between 4 and 5, 7 and 8, 3 and 4, and 2 and 3. So if we go to our number line, let's start at 2. So 2, 3, 4, 5, 6, 7, 8, and 9. And so our cube root of 119, that's pretty close to 5. So here would be the cube root of 119. Again, it's just before the 5. We had the cube root of 510, which was very close to 8. So the cube root of 510. We then also have the square root of 10, which is close to 3.1. So we would say maybe here, the square root of 10. And our very first number that we ordered was the square root of 5. That was close to 2.2. So if we go here, 2.2, maybe about there, that would be the square root of 5. So making sure that you're able to put those on the number line as well. All right. You're going to move on to your practice. If you have any questions, make sure you stop by during office hours or send me an email. Bye!